Um, what we have here is now on the left-hand side here, question C, and that is 12 to the power of x is equal to 30. Now, previously up in part A, when we had something like this, I went, boom, let's make both sides the same base. But I can't think of any way of manipulating 12 and 30 so that they get the same base. So I need to try something else. So we're going to start to use logarithms. I'm going to use logs in a different way to answer this question. Just stick with me as I go through this one. Remembering, guys, that whatever I do to the left-hand side of the equation, I need to do to the right-hand side of the equation. And I can really do anything I want to the left-hand side. As long as I do the exact same thing to the right-hand side, it's still going to give me the same values. So if we have 12 to the power of x equals 30, now I'm going to take a log. I'm going to take log base 10 of both sides. So I'm going to say, well, log of base 10 of 12 to the power of x is equal to log base 10 of 30. I can do that. I've taken the same step to both sides of the equation, so the equation still has the same values, it just now looks different. If we wanted to, we could have taken log base 2, we could have taken log base 30, we could even take log base of 300 if we wanted to. It doesn't really matter what log we took in this situation. However, I picked log base 10 because that's on your calculator. The log button on your calculator is log base 10. Alright, so that's why I've picked that. So now jumping back to the question, remember log base 10, that button's on our calculator, we're going to be able to use that. But over here, I'm going to simplify the left-hand side here by using our log laws. If I have log of 12 and what's in my log has a power, here I've got a power of x, remember that power moves to the front and it just becomes x multiplied by log of base 10 of 12 is equal to log base 10 of 30. That's true. And now if we look at the left-hand side, if it's x multiplied by log, to get x by itself, I'm going to divide both sides by log 10 of 12. So then we get x is equal to log base 10 of 30 over log base 10 of 12. Fractions are our friends here. And that's something we can now evaluate on our calculator. The log button on our calculator is log base 10. So on your calculator, you can now type log of 30 over log of 12. Your calculator will do log base 10. And log base 10, so log 10 of 30 over log 10 of 12, you hopefully will get 1.369 when you round it to 3 decimal places there. Okay, I said I'm going to do this two ways. So I'm going over here to method 2. And method 2, what I'm going to do is initially I'm going to rewrite 12 to the power of x equals 30 in logarithmic form. All right, that's different to method 1. In method 1, I took log of both sides. Here, I'm going to rewrite the equation. So instead of 12 to the power of x equals 30, I'm going to have x is equal to log base 12 of 30. All right, I've rewritten it in log form. What we're going to do is we're going to use this idea called change of base. And the change of base is literally, well, we don't like a base 12, right? It's not a button on our calculator. It's, we, through internet software, we can evaluate it, but on our handheld calculator, log base 12, it's not there. So we want to change this base to something that we have. So we want to change it to either log base 10, because remember the log button on your calculator is log base 10, or we can use the ln button because that is the log of the natural number. And remember, we're going to come back and talk about e as the natural number later on. But we could use ln. They're the two logs on our calculator. With change of base, the way that that works is, because 12 is our base, it becomes our denominator, and 30, it comes in our numerator. And what we literally do is we choose a log that's on our calculator. So I'm going to pick log base 10, and I'm going to write 30, and that is then over log base 10 of whatever base I had, which becomes 12. Now, hopefully, you can see right now that these two statements are now exactly the same. What we've done in method 1, the idea and the steps that we did in method 1, that's the logic and reasoning behind where the change of base idea or this change of base notion comes from. That when you end up taking log of both sides of an exponential and you carry it along, you get log base 10 of 30 over log base 10 of 12, which when we look on the right hand side there, log of base 12, that appears in the denominator there. So this is where change of base comes from. So the left hand side is literally just a long way of showing how you get change of base done. So, you know, in advance, we're quite happy for you to rewrite it in logarithmic form and then jump straight into change of base. And we said that is going to equal to x. So therefore, again, x is going to equal to 1.369 when we round it to 3 decimal places. Cool. Awesome. One more example to go. Just before we get to that example, there's just a little snapshot. You can pause that there to help explain what's going on with our change of base. Just some things that I try to remember, that 2 to the power of x becomes log base 2 of 8, because log base 2, the 2 becomes the base of our fraction, so it becomes the denominator, and well, we need something in the numerator, so that's where 8 goes in, and that log button is log base 10, and that's on our calculator, so we can use that to evaluate. Cool. All right, example 3, last example, and then you can get on with the worksheets. An investment of $1,000 is invested at a rate of 12% per annum, compounded monthly. How long will it take to double? Well, we have a compound interest kind of question here. So with compound interest, the future value or the final amount in the bank account is equal to the present value times 1 plus the interest rate per period to the power of the number of periods. All right, so 12% per annum, so 12% per annum equals 1% per month. And remember, our periods here are in months. So we have that, and we've been asked to find how long it doubles. So we've been literally just asked, when do we get $2,000? So using the future value formula, we want to know when is 2,000 equal to 1,000 outside of 1 plus 1 on 100, because that's 1%, to the power of n. Now let's tidy some things up here. When is 2,000 equal to 1,000 outside of 1.01 to the power of n? That's what I've been asked to solve. I can make this look even more simple. I'm going to divide both sides by 1,000 to get the 1.01 to the power of n by itself. So 2,000 divided by 1,000 is equal to 2. When does 2 equal 1.01 to the power of n? And if we have a look at this question now, after we've done our simplifying and substituting into formula, it's no different to the example that we did previously in C, where C was 12 to the power of x equals 30. Here we just have 1.01 to the power of n equals 2. N is going to be log of base 1.01 of 2. That's what we can write. Now that we have that, let's go through and use change of base. 1.01 is our base, so it's our denominator. 2 becomes our numerator. We've got log on our calculator, so I'm going to use log. So n is going to equal log base 10 of 2 over log base 10 of 1.01. When we evaluate that on our calculator, so log of 2 over log of 1.01, we get 69.66 blah blah blah, which would then become 70 months. After 74 months, this investment doubles. No guess and check required. Straight through, change of base. Thank you very much, logs. You are awesome. One of the biggest breakthroughs in mathematical history. It's allowed us to open up so much more understanding because of this idea of logs and how they work. Hopefully, those examples help you go through those worksheets at the end of this video, at the end of the announcement. Any questions, message me through Canvas. Otherwise, good luck, and I'll catch you guys later.